A sequence is a set of numbers that share one pattern. A pattern is a rule that dictates what numbers are part of a certain sequence. Take a look at this sequence. The values appear in a sequence are called terms. Each term has a position or order in the sequence. So 2 falls at the first position, 5 in the second position, and so forth. The variable n is used to denote order of terms in sequences. So 2 has n equals 1, 5 has n equals 2, and so on. The value of each term in a sequence is denoted by the variable a with subscript n. So a sub 1 is the value of the first term in this sequence. Therefore, a sub 1 equals 2, a sub 2 is 5, and so forth. The pattern rule for this sequence is true for all terms and is used to calculate the forthcoming terms of the sequence. Note the 3 dots at the end of the sequence indicate that the pattern goes on for unshown terms. The pattern rule for this sequence is n squared plus 1. This means to calculate the value of a term at any position, square the order n of that term, then add 1 to it. This calculates a sub n. Let's try the rule for the 10th term. N equals 10. Plug in 10 for n in the pattern rule. Square 10, which is 100, then add 1 to that. A sub 10 is 101. Same goes for the 35th term. N is 35. Square 35, that's 1,225. Then add 1 to that product. A sub 35 equals 1,226. An arithmetic sequence is a unique and common type of sequences where the terms increment or decrement by a fixed number. A current term of a sequence is usually referred to as a sub n and the term right before it as a sub n minus 1. The fixed increment or decrement is called the common difference and denoted by the variable d. To calculate d of any arithmetic sequence, subtract any term or a sub n minus the term right before it or a sub n minus 1. For this sequence, it's apparent that the common difference between a term and the one right prior to it is 4. So d equals 4. The next term in line can be calculated using d. Simply add the last known term to d. The 7th term, for example, is calculated by adding the 6th term or a sub 6 plus 4. It's 27. Similarly, a sub 8 is calculated using a sub 7. One question may come to mind is, can the 50th term be calculated using the common difference d? Yes, d can be added, as shown previously, to calculate terms 7 through 50. As you can see, this can be a daunting process. For this reason, a formula has been put together to jump right to any term in the sequence without having to find out the prior terms. To calculate any term a sub n, only the first term and the common difference of the sequence are needed. Let's try that to find a sub 50. Looking at the above sequence, a sub 1 obviously is 3. D is found by subtracting any term minus the one right before it. Here, 15 minus 11 is used. You can choose to use any other 2 consecutive terms. D is 4. Since a sub 50 is so to be calculated, then n equals 50. Next, plug in the values of n A sub 1 and D in the formula. The key element of using this formula correctly is following the proper order of operations. Evaluate the expression inside the parentheses first. That's 49. Then the multiplication holds the next priority. Multiply 4 times 49. That's 196. Finally, add this product to 3. The 50th term is 199. What's the 100th term of an arithmetic sequence that starts with 21 and 6? Here, the sequence is not given, but rather the first two terms are given. So A sub 1 is 21. Also, it is given that the sequence is arithmetic. Then, subtracting the second minus the first term yields the common difference. D is negative 15. This particular sequence is decrementing. N, of course, is 100. Now let's use the formula for A sub n. Plug in the values of n, A sub 1, and D. Execute the formula using order of operations. Subtract first, multiply. Remember, a negative number times a positive number gives a negative product. Finally, add. The 100th term is negative 1,464. The partial sum of a given arithmetic sequence is basically the sum of all terms from the first to a certain nth term. In this question, S sub 20 is the sum of all terms up to and including the 20th term. The formula for calculating the partial sum calls for the first term and the common difference. In this question, the arithmetic sequence gives terms up to the 5th term. Obviously, A sub 1 is 12.5. Note that decimal or fractional arithmetic sequences work the same way as whole number sequences. D can be calculated by subtracting any A sub n minus 1 from its corresponding A sub n. The common difference is 6.5, and n equals 20. Plug the known values of the three variables in the S sub n formula. Now the formula has become S sub 20 since it calculates this specific partial sum. The easiest but not necessarily the shortest way to evaluate this formula properly is to reduce the numerator to a single numerical value first, then divide that by 2. Evaluate the two expressions inside the square brackets from left to right. 2 times 12.5 is 25. Bring down the plus sign, then reduce the second expression to 19 times 6.5. Next, multiply 19 times 6.5, which is 123.5. Now add the two numbers inside the square brackets. That's 148.5. Multiply. Now the numerator is 2,970. Finally, divide the product by 2. The sum of the first 20 terms of this sequence is 1,485. A partial sum can be calculated knowing the first two terms of the arithmetic sequence. For this question, the first term, A sub 1, is negative 60. Using both the second and the first terms, calculate D. It's 13.15. Remember, subtracting negative 60 is the same as adding 60. N is 92 since S sub 92 is what is being calculated. Use the same formula as before. Plug in the values. Follow the proper order of operations. Start with the brackets. Multiply. multiply again, add, and divide. The sum of the first 92 terms is 49,525.9. What's the sum of the first 32 terms of an arithmetic sequence that start with 5 and 1/4 and its 32nd term is 25? Here, the beginning and the end terms of the sought partial sum are given. Note that this formula cannot be used simply because the common difference is not given nor can be concluded. For this, a simpler formula is used which calls for the first and the last terms. A sub 1 is 5 and 1/4. A sub 32 is 25 and n, of course, is 32. Plug in those values in the formula. Evaluate the sum inside the parentheses first. 5 and 1/4 plus 25 is 30 and 1/4. Before multiplying, change the whole number 32 to fraction form by simply adding 1 in the denominator. Then change the mixed number 30 and 1/4 to improper fraction by multiplying 30 times 4, then adding the product 120 to 1. The improper form of this number is 121 over 4. Now use the cancellation method to eliminate the greatest common factor, which is 4. The multiplication problem simplifies to 8 over 1 times 121 over 1. Multiply across. Now the fraction in the numerator is 968 over 1, which is essentially 968. Finally, divide over 2. S sub 32 is 484. A more sophisticated way to express the partial sum is using the sigma or the summation notation, where k indicates the order of the beginning term from where the sum starts and n represents the order of the end term to which the sum goes up to. The execution of the summation of a sub k is simply adding up all terms from initial value of k, which will always be 1 for the scope of this lesson, till the end term a sub n. So the summation of terms 1 up to n including the 133rd term is calculated using the same formula as before. Find d using the first two given terms. Plug in values and evaluate following proper order of operations. The partial sum of the first 133 terms is 98,154.